Hi guys, good evening. How's your day going on? Hi Talha,
Hello.
thanks and welcome to this session. So to all the attendees over here, so this is a session where we'll learn about how majorly Amazon is scaling their product or precisely like what Amazon is expect their engineers to do basically. So just to give you a very quick intro about what and how this session will go on. So I have a predefined set of questions, running question for Tala. So initially we'll discuss that with Tala, and obviously on the later half of this session, we'll open a Q&A for all the audience available over here. So without taking a much time, Tala, I request and obviously hand over the mic to you, and probably we can start with a brief introduction of yours.
Yes, sure.
Over to you.
So yeah, thank you very much. And let's get started. So as we were saying, I'll start with a brief intro about myself. So hi everyone again. My name is Talha Rahman. I'm currently a principal software engineer at Oracle Corporation, and I work with the health AI healthcare space. Uh, right before this position, I was at Amazon. I was at AWS as well, and I used to work for AWS Healthcare. So it's kind of like same industry, just different companies I'm working with. And I worked at Amazon for like around 5.5 years or so. My last team, what I was doing at AWS, I was a part of a team that launched a new AWS product called AWS Omics. So what AWS Omics is, it's like a purpose-built data processing service for processing like very large amounts of genomics data. So genomics data processing, meaning healthcare researchers, bioinformaticians, laboratories, universities, they have like terabytes of genomics data that they want to process. They want to run pattern matching, cancer detection algorithms, sequence matching, and sometimes those algorithms, those processing runs for like days together. So that kind of very large scale data processing system, that's what our service enables. And yeah, so that was my last team at AWS.
Sure, that's amazing. Yeah, yeah,
Yeah, sorry, I think your mic was muted for a bit.
yeah.
Yeah.
Exactly. I got it. So, Talha, on that note, I think we have some really good folks who have been here. Probably others will also join us. So let's just
Mhm.
kickstart this session.
Mhm.
So my first question is around the organization Amazon.
Mhm.
So tell me about like how right now you have moved to Oracle, but when you were a part of Amazon, so
Mhm.
how was your typical day looks like when you are working for Amazon?
Mhm. Okay. So when you are working from Amazon, I mean, typical day, it's kind of hard to put together a set of typical, like something that defines a typical day or describes a typical day, because it depends on what you're working on or what team or what your team is doing at the moment. So I can maybe give some examples of what somebody might expect to be doing while they're working for Amazon. So like I'll say that assuming that that person is like, let's say they're working, they are not on call. I'll get into the on call part a little bit later. I'll start with, let's say you're not on call, you're not maintaining a live cloud system or anything like that. So then you have your regular work. So typically what you do is like in the morning sometime, you'll probably start with the daily meeting. You'll give your status updates. And from the daily meeting, you'll learn what the priority for the day is. Is there any urgent issues that needs to be taken care of? Has there been any high severity bugs or any high like urgent customer requests and that kind of thing? So those things you'll get to learn. And then you'll give your status updates or hear from others on what they're working as well, if they're facing any issues, if they're facing any problems, or if they're stuck, or if they have any questions. And if they have questions in an area that you know very well, maybe you can sync up with them after the daily meeting and give them some direction and all that. Or if you have questions, you can ask those things as well. So yeah, that's typically how you can expect the start of the day. And then the rest of the day, again, depending on the task, would probably be like some some coding, some testing, that kind of thing. If you're working on a design task, then you'll be like doing some analysis, maybe reading different documentations, or writing your own design documentations. And on top of that, like you would obviously be like collaborating with other people, of course, depending on their task. But let's say if it's a larger task or a larger feature that you're working on, you may have to collaborate with other teams as well. Let's say what you're working on has a dependency on some system that another team maintains, so you may have to collaborate with them as well. So this is typically how it would go. So that's how it is. And as for the on-call part is typically would be more on the operational side. Operational side is like you'll have to, when you're maintaining this live system, you'll have to kind of look at tickets, look at bugs, look at different metrics, performance metrics, and always be aware that you know the status of the system at any given point, and you can identify any problems before the customer sees them. So that's kind of the operational part.
Oh, that's amazing. Like I can sense like on every vertical you have mentioned, like whether it's coding, whether it's
Mm,
reading documentation
mm,
and looking out the live data and everything. So that's very phenomenal, I would say. But I
mm.
think this is actually a mix of what I can say. You have worked approximately 6 years for Amazon, so I think that's a
Yes.
very good mix up. Yeah.
Yes.
All right, good to as of now. So on that part, one more question I am just putting up. So that is again a bit relevant for the organization Amazon. So what are the key engineering practices or principle that Amazon follows to ensure scalability for their
Mhm,
product?
mhm.
If
Okay.
you can throw some light, yeah.
Yes, sure. So, yeah, like some of the key engineering practices, I mean, in general, like Amazon, or like the teams within Amazon or orgs and all that, they kind of have like it's not so much that there is a centralized global list of principles or practices you have to follow. It's usually like kind of like orgs sometimes can make their own, organizations or teams can make their own decisions between depending on their case, and sometimes like different orgs may have like slightly different orgs may have a different engineering principle document that, okay, somebody like a group of senior engineers within one org has written this engineering principle document, another org might have their own document. The content of the documents isn't necessarily different. It's not like they're conflicting documents or anything. It's just that they may focus on, or they may have worded it differently, or have some some differences, or some depending on some orgs might prioritize some things more than others and that kind of thing. So that's kind of how it goes. However, some of the like the common themes or common engineering practices that I have gathered across my experience within Amazon is like one thing is like one thing it's pretty across all orgs, and all orgs take it seriously, is the operational readiness. Operational readiness, meaning that once your system goes live, once you launch your system, you have, or before you launch your system, you have to be fully ready to handle any kind of operational issues. Operational issues meaning that bugs, outages, what if one component fails, a part of your service fails, and how you'll handle them, how you'll recover. So those things you have to be ready in advance before you launch. So things like, for example, before you launch, you would need to have, I mean, of course, depends on the team, but you would have to have some sort of operational metrics and have it reviewed by a very senior engineer within the org, that kind of thing, or within the greater org with senior management. So operational metrics, meaning that can you just like metrics that can answer questions that just by looking at one screen, can you answer if there's a problem with your system? Or just by looking at one single place without having to go through a large number of charts or pages or that kind of thing, can you quickly tell if any customer is facing an issue, or if a customer is facing a failure, or if there is a outage, if there is a network failure or something of that sort, do you automatically get a ticket? Right. So those things you have to kind of be able to answer and have to be ready with like for every product or every system or every service you launch. And also, like, you need to have things like your runbook up to date and reviewed by the greater org and that kind of thing. So anybody who is managing the like anybody who's on call, or anybody who is, or even if they're not on call, they just joined, something happened, they just joined, they can just quickly look at the runbook and figure out what to do in these cases. So the common error scenarios, or potential error scenarios, or issues that you may have observed in the past, those have to be like well documented so that you can quickly recover and quickly maintain and all that. So this is kind of one big thing about like Amazon, what I've seen across all orgs, that you have to be operationally ready. Apart from that, like things like when building an architecture and those kind of things. Typically, I mean, these aren't the principles or good principles what I've seen, not very specific to Amazon. I think these are kind of general good engineering practices. Things like one thing is like building something which is, let's say, big enough to do the job, but not too big and complex on your first release, and then iterate over it. So kind of do an iterative building, iteratively build your system, and not build something too complicated at first. This is one. Another thing is like try to reduce the number of dependencies between different systems. So what that means is, like, for example, in AWS, you have, like, I don't know, hundreds and hundreds of different services. Previously, it was, I think, when it started, it was small, but right now they have a lot of products, a lot of different services. And even within the same domain or same area, you have multiple solutions. Like AWS has multiple database solutions, multiple data processing solutions, batch job. If you want to run a batch job, you want to have set up a compute host, they have multiple solutions, even within the same space. So you have all these solutions, all these components and all that. But when building building your service, or when building a software and all that, one principle is like try to limit the number of dependencies, unless it's absolutely required. But try to like make it simple, not have too many dependencies, not make it super complex. So those kind of things, those are another thing that Amazon follows as an engineering practice.
All right. So Tala, you mentioned about, like, there are few operational matrices that used to be followed. So if you could
Yes.
just share maybe one or two example of what exactly are the operational matrices.
Yes. So operational metrics at the very basic level, or at a very high level, let's say anytime you get an error in any part of your system, there should be a metrics. Like, you should see a graph that, okay, graph is flat, and then you get an error, there's a blip, or if and all that. If the error rate increases after a certain point, you should get like a higher, like you should get a higher severity ticket. So if it's like, let's say maybe one error in an hour, fine, maybe you get a lower severity ticket. But if it's suddenly from, instead of one, it climbs up to, I don't know, in 1 minute you get like 50 errors. So that is a cause of concern. So you should be able to track these errors. So that's kind of at the very high level, very basic, that any error that you see. Another thing is also being able to differentiate between what is your system error, like a system, or the error that is caused by your system, versus an error that is caused by, let's say, a request coming in from the customer. So if I were to speak in HTTP terms, so HTTP is typically like 400 or 4xx errors. That's like customer error. Customer is initiated or sent a bad request, a malformed request, or that kind of thing, or somebody is trying to even maybe launch an attack on our system, but that's another case. The other is like a 5xx error, like HTTP 5xx, meaning that there is a issue in your system, your server application through an exception. So those kind of things, you should be able to differentiate that thing. So yeah, this is kind of at a very basic or very minimum at the high level, that any error, any failure, anything, you're aware of it. You have a way to investigate it. You have a way to find the root cause and that kind of thing, and also escalate depending on the error rate, because higher error rates usually means obviously that your customers are probably seeing those errors, and you need to do something about it. Apart from that, like you can have more like drill down on these errors. Like, can you differentiate between like which customer had this error, or if it is it's it's not always going to be one customer, but it's probably going to be multiple. So can you separate out that, okay, this out of all these errors, this maybe 50% of their customer errors, and maybe 50% of these errors that you see in your system, that's because of internal traffic, internal errors, like system to system communication. So customers probably didn't see that error. So what are those custom errors that the customer saw, and are you able to drill down? So these are this is one. And apart from these errors and all that, others are kind of like just monitoring the usage and seeing if there is anything abnormal about it. So if you have, let's say, you're setting up a lot of hosts and all that, what is the memory usage, what is the CPU usage? Or if you need to set up hosts dynamically, meaning like at runtime you set up your Kubernetes cluster or KCS cluster and those kind of things. If there is any abnormal pattern over there, that on an average, let's say every hour you set up, you get 50 requests or 100 requests, but suddenly the requests have tripled or quadrupled or something like that. So then you should be able to first of all get notified, and second of all be able to quickly determine what the root cause is. So things like those, these are some of the operational things we look at.
All right, got it. So I think you already mentioned one of the things, like that's when there is a bug or any error has been reported. So that's where majorly the people or probably the team used to take on priority, and which is very obvious. So my next question is on a similar line. So can you share, like, maybe I would say error and bug are the side products. So for example, can you share a scalability problem that you might have encountered at Amazon, and probably how you or probably your team has dealt with it?
Yeah, sure. So like scalability problem is like how like we how well, like one scalability problem or one of the sorry, are you still there? I think your screen went blank for a little bit. Sorry.
Yeah. No,
Yeah. Okay.
yeah.
Okay. So yeah, one recent scalability problem I could think of is like what in my last team, what we were doing is like customers would, as I was saying, that how our product was, or how our service customers would use is like they would use for genomics data processing, and a part of that, this data processing, they need to set up like Kubernetes clusters, or set up like hosts at runtime. So let's say somebody wants to run a large amount of process a large amounts of genomics data. Say they want to process 1 terabyte, 5 terabytes of genomics data. So they come use our service. Our service would set up these hosts in the backend, run the processing, and tear them down so that customers only pay for the processing time that they need to process their data. They don't need to keep the hosts running and that kind of thing. Right. So what we were facing over there while like getting these while trying to acquire these hosts, and these hosts, they're not necessarily all like same capacity. Depending on how much data you want to process, you'll have different capacity requirements at different times. Like different customers, sometimes they'll have large data, sometimes smaller data. So you'll need smaller hosts for small data, a larger host for larger data. So that kind of thing. So now what we were seeing is that one scalability problem we were seeing is like, even though AWS data centers, they're like pretty big, they have like, I don't know, millions and millions of hosts and all that. You can set up virtual clusters and those kind of things. However, they do have like limits for every service and everything. So some limits meaning that even though we are a internal AWS service, we're an internal AWS service, we can't just go and take or set up like 5,000 hosts at any time, right? They have certain limits. You cannot just use up all the resources in the data centers. So what was happening was that our customers, sometimes what they would see especially at like busy periods and all that in certain regions, busier regions obviously, is like when they try to come and process their data, sometimes their request, like our request for async, and they can check the status, but what they would see that their request is stuck in pending state for a long time. Why? Because there isn't enough resources to kind of acquire those resources and give those to the acquire the resources and process the customer jobs and all that. So this became like a pretty big like a major customer problem, because we didn't really have any kind of like priority or anything like that at request. We just process the requests as they come along. So a important customer who's like a big major customer of AWS, they come and they're probably experimenting with something, and suddenly their request gets stuck. So that's a very bad customer experience, right? And so this is what we are facing. And on top of that, some of the customers would like request for resources like hosts that were scarce to begin with, like GPUs. GPUs are like, as you probably know, not all data centers have a lot of GPUs. AWS has some, but it's a pretty scarce resource. So if the GPUs in one data center are all used and all that, then the customer request will get blocked and that kind of thing. So this is one like a kind of like scalability problem we faced, and yeah, it is a scalability problem on the I mean, it's not so much like scalability in the sense that we need bigger CPU or memory, but it is still a scalability problem that we're running out of host. So how we ended up solving it is like what we did is like we did a few things. There wasn't like one single solutions. One was that if you could distribute the load across different availability zones. So within the region, AWS has availability zones, and if we could like redirect the request to a particular availability zone, that would kind of ease the contention a little bit. And we came up with a way after, like, there wasn't any like simple way of knowing this, but after working with the some of the internal AWS teams and like the ones that are like KCS teams, like Kubernetes teams within AWS and all that, we came up with a way of like hitting an internal API and kind of getting an estimate of the number of available hosts, and then kind of redirecting them across different availability zones. So this was one. Another one was like we leveraged there's a AWS feature, it's AWS service of auto scaling groups. So auto scaling groups is like you kind of scale up your group, or you scale down your group. So depending on how much like load we predict, we try to kind of predict the load in advance, that okay, we know that at this time there's a demand spikes up, and at this time it goes down. So we would try to scale up. We would scale up our auto scaling group and scale down our auto scaling group with the number of hosts based on the demand up and down. So this is another thing we had to do. And as for the GPUs, since those are a scarce resource, so for that, we actually, like, all these mechanisms didn't really work because the resources have to be there in the first place. So for the GPUs, what we did is like GPUs, it was more of a talking with the customer and kind of explaining to them kind of solution. So what we do is like not all customers needed GPUs. So only the customers who actually need GPUs allow them to use GPUs, and list like their accounts or specific accounts that they're using to run like GPU workloads, list those accounts so that they can start GPUs. Other accounts won't be able to start GPUs right away. So again, like not maybe a very technical solution, but if you don't have enough GPUs, the other option, of course, is to kind of see that, okay, how can you make it better for the customers and they understand and if they're happy with the solution.
Sure. So eventually, I completely agree with what you said, because speaking about organization like AWS, they might be having the major problems they are already being solving as of now. So these
Mhm.
small things which should be getting live in a near future, so they are very important.
Yep.
All right, that's wonderful. So I have one or two more questions. Also, I request the audience, if you have any set of running question, feel free to raise those questions in the Q&A section. So Talat, now my questions are directly related to probably the candidates who are majorly here. So for them, about the interview processes and all. So
Mhm.
in that category, I believe you have been with Amazon for around 5.5 to 6 years.
Mhm.
I'm sure you have taken a lot of interviews over there as well. In terms
Yes.
of scalability, I'm talking about.
Mhm.
So my exact question is, when you are interviewing a candidate for
Mhm.
the role of on the system design interview,
Mhm.
what are the key factors you look up for?
Mhm. Okay. So when interviewing a candidate, key factors, especially when it comes to system design side, I think, I mean, in general, the guidance within Amazon, and also what I would look for is like some of the well, first I'll start with the general expectations is like, okay, does the candidate does the candidate try to attempt to understand the question first, clarify requirements, go through the questions, and then try to solve the problem? So these things. Also, do they take like what kind of approach do they take? Are they, are they able to once the problem has been clarified and kind of the problem has been defined, or the solution or the direction has been defined, let's say, are they able to break down a bigger problem into smaller pieces and then focus on those one by one, or that kind of thing? Then also, like, do they have an actual understanding of actual understanding of their solution? Are they able to clearly explain their solution, clearly explain each component, and up to what level they're able to explain? And another part would be that if, let's say, something needed to be changed in their solution, in their architecture or something like this, are they able to identify where the change needs to be, or kind of get to the exact point that, okay, this is where the change needs to be made, and are they able to kind of readjust the system and maybe make those architectural changes and that kind of thing? And on top of that, like on top of all this, this is kind of like the general, what is exam, what people would look for in an interview in general, the interviewers at Amazon at least. And on top of that, like, there are some other things, maybe me, and I've seen other interviewers would probably focus on that as well, is like trying to get a sense of, like, by talking with the candidate and going through the solutions, is like, well, the solutions they're offering, or the solutions they're giving, do they really understand their solution? Like, the understanding might come from work experience. It might come from it might even come from like reading or preparing for interviews. That is fine. Doesn't matter where they picked it up, but as long as they actually understand the solution and able to explain it, in simple terms, and able to kind of like explain, even if some of the like something little changes a little bit here and there, are they able to clearly explain? As opposed to, let's say, somebody who knows the right answer, but it sounds like, they may have read it from somewhere but didn't really understand it. So that's usually a kind of like a common, what should I say, like that is something what you'd want, that interviewers would want to like probe on in as interview, especially the system design part. Reason being that, for a coding question, programming and all that, there's usually like one or two best solution for any coding problem. Versus on the system design side, there isn't really a single best solution, and you just give the solution and that's it, you have the best answer. No, it's more about understanding, able to explain, and that kind of thing. So that's why this second part, as to trying to see that does the candidate really understand what's going on, as opposed to just knowing the one single right solution, right?
Right. So I think you have very clearly instructed about what are the major expectations from our candidate that an
Mhm.
interviewer used to have.
Mhm.
I'll just slightly change this question.
Mhm.
So my next question is on the line, like, because in the past you have taken a lot of interviews. So in that category, probably the audience which we have, or they might be taking up, or probably they'll be sitting up for the next round of interviews as well in various
Mhm.
other organizations.
Mhm.
So what are the common pitfalls, or I would say misconception that you have seen in the tech professionals while
Mhm.
they are going for the interviews, or let's say if they are preparing for their interviews?
Mhm. While they are preparing or going for their interviews, I think one common misconception probably would be, and I think this kind of impacts that, well, it impacts, I've seen many people, is like thinking that the interview is necessarily going to be super difficult and kind of like being a little nervous about it. I mean, I understand that, interviewing is, people tend to be a little nervous. Even when I go for an interview, I sometimes feel a little nervous and all that. But in general, like, yes, there can be some cases when the interviewers ask for a very difficult question, and it's very difficult to answer within the given time and all that. But I mean, it is possible, and maybe some candidates may have had that experience, that they ask very difficult, complicated questions. But in general, interviewers, when they are interviewing and all that, I'd say that they're probably or in most cases, or from at least what I've seen, or at least what the guidance is like, you should try to see if like the candidate is understanding the basics well, and they're confident, they know what they're saying about, and they understand it very well, and they're able to explain it. That's kind of the thing. So like that's what's being focused, that's what people are focusing on. And quite often, like it's not always expected that you give the perfect solution or perfect answer uh, in an interview. Even if you can't give the perfect solution or perfect answer, if you can demonstrate that you actually understand the problem and would be able to solve the problem, quite often that's a like it would be a positive signal that, okay, this person maybe ran out of time or whatever, but they would be able to actually solve it or provide a solution and that kind of thing. And on the contrary, like sometimes providing very perfect uh, you know practiced responses or perfect code sometimes can be a red flag, because that sometimes signals that the is the candidate, especially in virtual interviews and all that, is the candidate, did they really understand and solve the problem on the spot, or is it like they have somehow memorized it, or are they getting the code from somewhere and they're just reproducing it, and that kind of thing. So sometimes that can be a red, like it can act in counter that producing everything is perfect and all.
All right, all right. Sure. So I think, Tala, like, there are multiple questions running in the Q&A box.
Mhm.
So
Mhm.
we should jump on it.
Sure.
Before that, just a quick announcement to all the IK alums and the learners. So very soon in the month of April, we are planning first offline meetup. So to the folks who are in the Bay Area, or who might come to Bay Area, so just keep an eye on your email. So within this week, you'll receive the email about the invite for the offline meetup. So if you reside in the Bay Area, so it's my first hand invitation, or you can say it's a request. You can join those events. So just keep an eye during this week. So that's it. With that, I think I'll quickly move to the Q&A section. So, Tala, any question you want to take on priority first?
No, I don't really have any specific priority, I think. I mean, I don't know how you typically do it. You can maybe go from top to bottom, or
All right. So I'll just follow the same strategy. The first question is from Frank. So he asks,
Yeah.
could you help us understand a typical product life cycle?
Typical product like life cycle, it would be something like, you start kind of like, start kind of at the initial state, and then it's kind of like the planning state. Then there is some planning state, and then there is like some sort of analysis state. Analysis state as in meaning that it's more like, who the customers would be, how they would be using this product, what that kind of thing. That part is, at that point, up to that point, it isn't really any, there isn't anything, technical implementation or anything, design or anything going on at that point. Technical design usually starts at the next step, which is like at that point, the product has been like all these decisions have already been made, that who the customer is going to be, what the customer's experience is going to be like, and all that. So now we start with the implementation. So the implementation typically there would be some planning stage, some like high level design, some high level architecture, those kind of stage. And then like you'll have the product broken down into phases, and then the development work will be going on, and then you develop, you implement, and all that. And you would have like an initial release state, like maybe a beta release at that point. Or you can even have like an internal release. Internal release means you do a release, but you don't release it to anybody else outside your internal org. Then you can do like a beta release. Beta release means that you choose a select number of customers. Only those customers can use your product. And then eventually there will be like a GA release, GA meaning generally available release, that then you kind of like release to the general public, so the broader, basically everybody. So that's kind of how it goes. And of course, after a while, if a decision is made that this system or product is not going to be used anymore, so then there is also a tear down or deprecation phase. So deprecation, you would kind of maybe stop development, so no new features, just bug fixes, and then eventually deprecate the product and stop it altogether. So that's kind of typically how it would go.
All right. Now I can see like there are set of 2 to 3 questions from
A
various.
quick question. Is there a way to ask, did I answer the question, or did the person who asked, he had any follow-up questions?
Yeah. So Frank, if you are here in the call, so if you have any follow-up question for Talha, so feel free. Also, by then, I request other participants who have raised their questions. So I think, yeah. So other participants, if they have any questions, so just raise your hand. So what I can do, I can just add you in this call. So directly, you can just ask your questions with Talha. So feel free to raise your hands.
I think Frank has just raised his hand.
Yeah, I'm just adding him to the call. All right, Frank, feel free to unmute and put up your follow-up question.
Yes, thanks for the great answer. My follow-up question would be like for example, particularly for the AI product, where would the request coming from? Would that be an internal client, or would that be someone like outside? Or yeah. So that's basically my follow-up question.
Yes, so it would depend, of course, like who your customer is and what product you are developing or you're working on, right? So if you're working on, let's say, your service is basically setting up large amounts of GPU to do AI data processing, so that would probably be a internal internal kind of request, or internal team would give you that request, that, okay, how can we quickly set up GPUs, or how can we configure GPUs to give the optimum performance? How can we set up networks for GPUs, or network for our hosts? So those kind of things. If the product itself is being used by external customers, if it's AI and all that, then of course that would like the product request or what the product would look like would come from some sort of like market analysis as to see like who the customer, like what people working in the AI space, what they're doing, what kind of system they need, what kind of what are their use cases, how can we support their use cases, so those kind of things, right?
Yes. Yep. Thanks. Thanks
Yeah,
for the good answer.
yeah, you're welcome.
Sure thing. So I'm just adding you, Arif, to the panel. Hi, Arif. You are on the panel. Please feel free to ask your question.
Thank you. Yeah, I actually had a question regarding the organizational hierarchy. I joined a bit late. I wasn't sure if Talha is with Amazon or he's with Oracle. But regardless, I wanted to understand about AWS's like organizational hierarchy or the structure in terms of, you mentioned about monitoring these KPIs for different applications or systems and being on call. So does it fall within the developers realm, or there are different operational resources to do the KPI monitoring?
Okay.
That's number one. And another thing is, given this new trend with AI or ML based pipelines, so for the legacy system, are they still relying on those KPIs, or they are also monitoring logs and creating different models to detect anomalies in their systems?
Okay. So I'll answer your first part. I think you asked about the organizational hierarchy and those kind of things. So far as engineering organizations go, or engineering teams goes, it's at Amazon at least, it's pretty much flat. Flat meaning that you have an engineering team, everybody does their work, and they have a manager, and that's about it. So engineering teams or engineering organizations are more or less flat. Now, as for managers, they have their own hierarchy, and like, you have manager, senior manager, director, VP, SVP, and then finally CEO, something of this sort. So that's kind of the hierarchy overall. As for KPIs and monitoring those kind of things, KPIs monitoring, when you're on call, you do your own monitoring, you monitor your own service, you look at your own KPIs. And after your on-call shift is over, which is, well, not just your on-call shift is over, like weekly or periodically, sometimes it can be like daily or periodically, daily or weekly or bi-weekly or whatever. You have to attend a meeting where, everybody in the org, they, like other people or other teams or other senior manager of the org can attend, and where you have to present any operational issues that you faced and how the last week went. Were there any major failures, major customer issues, any customer complaints, any outages? So those kind of things you have to explain, and we have to go through them and see if there are any action items, if anything has to be done to avoid these kind of operational issues in the future and all that. And another thing you mentioned, I think, is with the AI, that what we're doing with the AI. So AI, or how we are managing operational issues, and is AI being used to manage and all that. So far, all these operational metrics or these things, it's like we're still using the existing logs and metrics and charts and everything. That has not been like deprecated or anything like that. That infrastructure, that setup and everything, that is still there. Using AI on top of this, there are some like products or some teams kind of like implementing or integrating with AI, that AI will tell us what the issue is, or AI will get to the root cause of this. Those are still kind of being developed. It's not like, everybody has, the whole org or whole team has just switched everything to AI, not like that. But they're still being developed. So eventually, maybe sometime in the future, it might be that there will be more usage of AI on top of the existing logs and metrics and monitors and that kind of thing. Right. So yeah, does that answer your question?
Yeah, yeah, it does. One additional question is just like how Google has Gemini, or um, Microsoft or OpenAI has a free tier for to um, try out their AI engine. Is there any free tier for AWS or on Amazon?
Amazon, I mean, I don't know about the like how much they charge, but like, is it free or not? But I think that any AWS product, you should have a free tier. Usually any AWS product, you have a free, like up to a certain amount of usage, it's like free, and after that you get charged. And AWS has like a suite of AWS products and AWS different things, models, and all that you can test out. And again, I'm not 100% sure about how an external user would get charged, but I would think that there should be a free tier that you should be able to kind of set it up and experiment with it.
All right, thank you very much.
Yeah, you're welcome.
All right, Darif, thanks for your putting up the question and coming on the call. So by then, I think there are a few more folks who have been asking a couple of questions. So Pratap, if you are on this call, so just raise your hand. I'll add you on the panel. And same for Sentinel Nathan, or maybe anyone else who have a question for Talha. So feel free to raise your hand. I'll add you on the call. All right. So, Pratap, you are on the panel. Feel free to unmute yourself and go ahead with your question.
Oh, thank you. Hey, Talha, this is Pratap.
Yeah, hi. Yeah.
I have two questions. One question is actually, can you discuss any lessons learned or mistakes made in the past regarding scalability? Because particularly we're interested to know more about your experience. So how you apply them to your work, basically, when you learn those lessons.
Okay. And I think your other question was that how do you ensure the scalability is built into the design and architecture of a system from the outset rather than as an afterthought, right?
Correct. Yeah.
Okay, so maybe I'll start with the second one first. So how do you design or ensure that your scalability is built into design and architecture of a system and all that as an outset rather than afterthought? So it's like, I mean, there are some principles that you can apply to kind of like ensure that this is taken care of. One common pattern or principle is like, make sure that in your system, like you have different components in your system and all that. So ensure that these dependencies between these systems or different components, these are like pretty well defined, that what the dependency is and what each component does and how they interact and all that. So that way, if let's say you see a scalability problem in one component, right? So you can scale that one single component, right? You don't need to scale like the whole system or re-architect the whole system. The dependencies are very clearly defined, and it's not dependence. It's not like different components are kind of interdependent and it's complicated. No, it's very clearly marked dependencies. And so if that one component is one component you need to scale, like you need to scale up that one component or scale it down, you can do it without impacting any other parts of the system. And if, let's say, you need to even change out that one component, right, then you can change it out without heavily impacting other parts of the system. Example of this, common example that comes to mind is like the database. So when you, let's say you have a database and you're like you have like well-defined criteria is like when you access the database and how you access the data and which data you keep in cache versus what is in the database and all that. And if you see your database is facing scalability issues, right, you can just change, maybe either scale up the database, get more number of hosts, and if that doesn't work, maybe slightly change change the type of the database or get you can go for a different database, or maybe reconfigure your database settings to be more scalable, support more data, that kind of thing. Like one example I can think of, one time in the past, we were working with a AWS Aurora serverless database, and Aurora serverless means that the compute hosts are set up on the fly at runtime, but that was not scaling. So because we had very clearly well-defined the database interfaces and entry points and things like that, from Aurora serverless we went to Aurora server full database, which is that means that your hosts are always up. So then we didn't really need to touch any part of our system. Our system became scalable, or basically fixed or got past those scalability issues, and without doing any major re-architecture or any increased latency or any downtime or anything like that. We were able to just swap the database live, like in a running system with live customers. We were able to do it because this was very clearly marked and very clearly defined and all that. So this is kind of one example. And second is, I think your other question is, or basically not your second or first question, can you discuss any lessons learned or mistakes made in the past regarding scalability and how you have adjusted your approach as a result? I mean, there are several. I think one big learning or big, big important lessons learned, I would say, is at least in when using in a cloud native environment like AWS, you're developing on AWS. I think one important thing is know your dependencies very well. What that means is that let's say you're building your system, you're building your service and everything, and it depends on other AWS services, right? So AWS services, you go and do a quick Google search, or you read some internal document and all that. Getting started is very quick and easy, right? You download a bit of software, or you download the client, or you set up some configuration. Within 5 minutes, you get started, and you start using it. However, in a live production system and all that, you would probably want to be a little more careful. So read the whole document before you go live. Understand all the complexities, all the nuances, all the service guarantees, and all these things that these services make, because it's all there in the documentation. What we have seen in the past is since there is a quick start, people, when they start out, they do a quick start. They get it set up, but they haven't read through all the documentation. Things like, for example, when the service would start throttling your request. So the service will accept your request up to a certain TPS, certain amount. After that, it might start throttling it. But since you can probably get around that throttling by if you had requested a higher limit in advance, but maybe you missed that part, didn't go through all the document. And then in a live system, when you have customers, suddenly your system got throttled and the customers are seeing an outage and that kind of thing. So this is, I think, an important lesson, to know your dependencies very well and read the document and understand all the nuances, all the pitfalls and all that of all your dependents very well. So yeah, does that answer your question? And do you have any follow-ups?
Yeah, thank you so much, Talha. I think, yeah, I have one last follow-up question, if you don't mind.
Yeah.
I'm not sure.
Yeah.
Is it okay
Yeah.
if you can?
Yeah. Yes, please go ahead.
On the scalability part, if the RPS actually coming abruptly on some days, like a holidays time or something. So how the holiday spike, how do you manage the scalability? Do you need to manage the cross-functional teams? Because there are some downstream services which we are calling, right? So how do we ensure the communicating across the teams, basically, to make sure it's not actually a cascading failure, right? So how do we ensure it's addressed properly to handle the customer unexpected spike?
Yeah, so unexpected spike is well, first thing is you probably should you should monitor any spikes, right? Like any high spikes and all that, and kind of monitor and be aware that what your spikes look like, and if it you should be able to kind of step in even if before it gets to the point of failure. So let's say your service would start failing at, I don't know, like 100 TPS or something. So at around 50, 60, you should already kind of like start throttling and start monitoring and all that. And you should have all that checks in place, right? And as for like these kind of holiday spikes or holiday spikes typically happen on the retail side, but it can happen on the AWS, like dependent AWS services as well. So for those holiday spikes, again, like there are certain mechanisms of how you like handle these cases. One of them, I think, like a famous one was, I think, a few years ago during Amazon Prime Day, there was like a huge spike, and there was also a temporary outage for the Amazon, and that was probably maybe only time, or maybe even one of the few times in Amazon history that Amazon.com was not working. But it was a huge spike, and we did have like a very like thorough review of this from like very senior engineers from all over the company and all that, and they wrote a document and all that. So some of the things that came from that document is like one is like, ensure that you have these kind of limits in place, throttling limits, all these limits in place for all systems, even internal systems, internal API calls. This is kind of one thing. Another thing is like try to avoid retry storms. Retry storms meaning that, let's say you're trying to communicate with the system isn't responding in time. So don't send 10 more retry requests. Retry request, what you do is like, I mean, there are different strategies. The most common or most popular one is something called an exponential backoff. Exponential backoff meaning that you send one request. Let's say you did not get a response. First wait 2 seconds, then wait 4 seconds, then wait 8 seconds, 16 seconds, 32 seconds. So have some gaps between your retries instead of sending hundreds and hundreds of requests and bringing the system further down. So this is another one that came up.
Thank you so much. That's all I have.
Yep.
Thanks.
Yeah, you're
All
welcome.
right, sure. So I think there is one question for me that's from the Ravi. So Ravi is asking about the location in Bay Area. So right now, Ravi, I would say let's keep it under the curtain. So within this week, for sure, you and the other participant will be getting an update on email and as well as on the alumni Discord server. Okay, by then, Sentinel, Nathan, I am just adding you on the call. So feel free to unmute yourself and go on with your question. Also, to other participants over there in the call, I think you have joined the alumni Discord server by IK. If not, just ping me. I'll share you the link. By then, Senti, you are on the call, please.
Yeah, hi Talha.
Hello.
So, yeah, I had this question when you were trying to explain that the server hosts are not responding because like they were waiting infinitely for resources. So I assume that sometimes the customer has chosen a single region that is nearest to their their location, their servers, to process the request faster. So do you like suggest customers, whenever there is a peak time, to use the next available server? Does it happen automatically, or they have to enable that multi-region then it would be possible for them to to cater their service?
Okay. So it would depend on, like how the customer is setting up. Is the customer setting up their own host, or they're just hitting an API endpoint that the service is providing? If the customer is setting up their own hosts, right, their own infrastructure, their own database and all that, then that means that the customer in this case is the developer of the service, right? So in this case, the customer needs to be aware that, or make provisions that, okay, do they need to be available in multiple regions, or do they need to be available in different availability zones within the same region? So as far as AWS regions goes, within the same region, there are usually like at least 2 or 3 availability zones. Some larger regions have more. So do you need to be available in all regions? So if one zone goes down, it's still available. So that's in this case, the customer kind of needs to set up their infrastructure and all that, because in that case, the customer is the kind of the developer of the system, or they're setting up the infrastructure and that kind of thing. However, if the customer is kind of like an end user, they're just hitting an API, like they're hitting the API from their phone or their app or something of this sort, and somebody else, like we are setting up the system or developer of the system, then we obviously would be needing to handle this case. That do you need to be present in multiple regions, or is one region enough, or how do you handle the case if one region fails? So those cases. Is that kind of where you were getting, or did you?
The second one. I was asking about the second one.
Yes. So second one, so second part is like as I was saying that customer, let's say they're not going to be setting up their own region or anything. They're just going to hit an API and it should work and all that. So again, it would depend on how you as the developer, the developer of the system, how they want the behavior to be like that. If it's like something like an app or something of that sort, that they're hitting an API or they have an app, and if the app wants to be available or go on to the next available region, so that's also fine. If the user is like trying to, let's say, access AWS directly, or setting up infrastructure AWS resources directly, like AWS or any cloud provider in general has these concepts of regions and all that. And what they would do, or what they'll typically do, is like each region is kept separate intentionally so that there is no interdependency. So let's say I'm trying to set up a database in region 1 and that region is down. AWS or cloud provider is not automatically going to set up that database in region 2, right? The customer or whoever is trying to set it up, they have to make the decision that do they want to go in another region and set up that database over there, right? A cloud provider will intentionally make your resources region specific. They won't automatically set up resources in multiple regions just because one region is down. Does that answer your question?
Mm-hmm. Yeah, sure.
Okay.
And
did you had some more questions, I think?
Yeah, like I've been trying for applying for a data engineering role. So I just wanted, like, if you can share some key skill sets that you require for data engineer, and if we have done any interview, is there a cooling period?
Okay. So one thing is, like, the interviews I have done is pretty much all like software engineer. I have done some front-end engineer interviews as well. Data engineer, I haven't really done the data engineer interviews. So again, like I don't really have the direct experience of what questions are asked in a data engineer interview and all that. But I would think that they would ask some maybe coding questions, maybe something to do with processing data, or typically a problem that you would face when trying to, let's say, join or process or filter or sort data. So kind of like coding questions that are more adjusted to the data engineering domain. That's what I think they would be asking. And also, other than that, I think data engineer, they'd probably ask possibly like database questions, database design question, SQL questions. So those kind of things they would probably be asking. So that's what I think. As for the cooling period, I think the standard cooling period at Amazon for all roles, I think, is like 1 year. 1 year, like after you've attended, let's say, a on-site loop, and then you didn't go on to the next step, then standard, I think, is 1 year from what I recall last. I don't think it has changed recently. But you can ask that to your recruiter. The recruiter would have the latest information regarding these things. But I think it's in general 1 year.
Okay. And do you suggest anyone applying for Amazon knowledge of both the AWS cloud systems? Will it be an upper hand?
It definitely doesn't hurt to know AWS well, right? If you know AWS or if you have some knowledge, definitely it's good. But that knowledge of AWS isn't necessarily the like the deciding factor, right? It will depend on like if let's say somebody does not know AWS, but they have they have skills or they have knowledge, they can demonstrate, maybe not specific to AWS. That's perfectly fine. It's not that having AWS will having AWS knowledge will necessarily, get anybody some extra points and all that. Of course, if let's say it could be the case that somebody says that, okay, how do you solve this problem, or how do you design a database? You could say that, okay, this is my answer is going to be in the context of, let's say, some AWS solution or how AWS does it, and you can probably provide your answers using AWS solution as an example. But again, like, it doesn't really matter whether your answer is giving a the environment you're talking about is AWS or Azure or Google Cloud or something else. As long as you can give the right answer, that's what counts.
Yeah, thank you, Talha. That's all I
You're
have.
welcome.
All right. So Tala, I think we are already on time, but if you permit, like there is one very similar question from Rajiv.
Yeah.
So if you permit, can I add him
Yeah.
to the call and probably
Yes.
continue?
Yes. Sure. Yes. Sure.
Sure. So Rajiv, you are on the call. Feel free to unmute and go ahead with the question. Rajiv, please unmute yourself. Rajiv, just a last call. If you are listening, please unmute yourself and go ahead with this question. Go ahead with your question. All right. So I think he's getting some issues. So Tala, one last question from my end.
Yep.
So I know you have been very actively taking part or probably staying updated with all your system design or maybe scalability development which are happening around the globe. So maybe you want to share any resource, any blog, or any podcast that you feel can be useful for the audience?
Yes, sure. So one blog that comes to mind is the AWS engineering blog. So you can they have a lot of different content, a lot of different they talk about a lot of different engineering problems and all that. So that and there's a it's pretty active. A lot of teams, they do posts and all these things. They do, like, there are teams or there are people who kind of like update or post in there like pretty regularly. So this is one thing you can keep yourself updated and all that. Another one I follow is the Netflix engineering blog. So that's their engineering blog is also pretty active. Lots of articles, lots of like design problems they discuss and all that. However, like, again, like this is kind of what I follow or I sometimes read, but it's not that you necessarily have to do this. There are plenty of good engineering blogs and tech blogs out there. I mean, a simple Google search will probably give you many different options, and yeah, you can have a look and see what you like, and you can take it take it from there.
All right, sure. So thanks, Tala. Thanks for the time.
I think we have one hand raised.
Oh, just a second. Yeah, I'm so sorry.
Yeah.
So yeah, SR is your. I think you are they are the initial. So I'm just adding you to the panel. So yeah, SR, if you can unmute and go ahead with your question.
Hi, am I audible?
Yeah, please.
Yes.
Yeah, sorry for the late question. Actually, it just came to mind. Suppose you are the head of AWS team, and for the non-blackout team in the sense like to care of any security issues or anything like that, and blackout happens, then what is your steps till the time you recover the blackout as a head?
Yeah, as a head till we recover, the first first step is having a awareness or measuring, being able to measure the customer impact. Customer impact meaning that how many customers we are trying to access our resources during this blackout or when this issue is happening. Who are these customers? What kind of issues they're facing? And what accounts are there and all that, and having kind of like a live view of these customers issues and who these customers are, and making the customers, I mean, depending on the length of the blackout, if it's like a very small amount and we can recover, then maybe you don't need to do that, like notify the customers right away. But if the blackout is going on for a while, like let's say you're more than like, I don't know, more than a few minutes and you can't recover, or you haven't figured out a way to recover and all that, you should notify the customers as soon as possible. Reach out to their account managers, and through their account managers have them talk to the customers, make the customers aware that we are facing some issues, but we are on top of it. We are aware of this, so that customers don't feel like nothing is working or their system is not working or nobody is looking into it and all that. Give them the customers that yes, we are looking, we are actively investigating, and like make sure that is the customer side is being taken care of. So this is kind of the number one priority. And second, of course, would be taking the steps to recover. So taking the steps to recover typically how it goes is like we would quickly assemble a kind of like a war room, like a battle room or a war room. So we quickly set up a call, get all the relevant parties, get everybody get everybody we need on the call. If see that which area is failing, what part is failing, get all the relevant people in the call, page them. If they don't respond within a certain time, like it's taken care of automatically. They will page their manager and then their manager and all that. So get all the relevant people together in a kind of like a virtual room or like a battle room kind of thing, and then kind of like look at the issue and try to solve it, and kind of try to see like how you can recover, what steps you need to do, what are the different things you need to do. And in parallel to all this, keep everybody updated. Everybody updated includes like both internal and external stakeholders, basically customers. So basically we keep everybody, as in all the account managers, everybody updated. Every, let's say maybe 10 minutes, 15 minutes, we give a status update. This is what we're doing. Previously we tried this did not work. Now we are trying this. So kind of give regular updates, and make sure have these updates kind of posted so that everybody can see them. So anybody who joins the call or any account manager who wants to update the customer accounts they maintain, so they can look and then give their customers an update that this is what we are doing. So kind of keep posting updates, keep everybody updated, keep everybody in the loop, and at the same time kind of like resolve the issue, or try to work to resolve the issue, get any help you need, and eventually once the issue is resolved, then of course you give a status update, and then you kind of maybe later on you do a postmortem as why the issue occurred in the first place, how we can avoid those issues in the future. So those kind of things. Does that answer your question? And did you have any follow-ups?
No, it didn't. Thank you.
Okay.
All right. So thanks, Talha, for joining up this session and eventually enlightening all of us with your valuable, I would say, thoughts which you have been carrying in your experience. So thanks a lot on that side.
Thank you. Yes, thank you very much.
And to all the attendees, it will be really great if you just go on and rate the session or probably give your feedback for the session. And rest, we are just good to go and sign off.
All right. Thank you, everybody. Thank you for attending, and have a great evening, or if it's morning at your place, morning, where depending on where you are. Thank you, everybody. Bye.
Okay. Bye. Also, to the attendees right now, if you have any suggestions for the community, feel free to share on the chat, or maybe if you want to talk, so just feel free to do that. Rest, you can drop off the call. All right, so I think we are good to go. Thanks for your time. Have a great evening ahead. Bye-bye.